Well, hello algebra. We got simplifying expressions with exponents part 3 today. Still looking at all of the skills about exponents that we've been learning for the last couple of weeks. Skills 44, 45, 46, and 47, which will show up in the skill quiz later this week. Again, on the intro page here to the assignment, you got like your notes page. There are all of the different properties about exponents that we have learned over the last couple of weeks, just like the last couple of times. So this assignment doesn't have 2 of each type of problem, so I want to make sure I hit all the different types of problems, but let's go ahead and start here at question number 1. Simplify the expression completely. You got y to the power of 15 over y to the power of 15. Any number divided by itself equals 1. Uno. Let's do question 2. Okay, so some of these problems are going to be similar to ones we've done, right? We're just all week. We're practicing more practice. And so we get a lot of the same type of problems. All right, well, first of all, this 2 right there, no exponent. It's just a number. Don't try to do any exponent stuff on it. This one, there is no matching number on the top. So it is a fraction, but it's got like an invisible 1 up there. That's the other part of my fraction. I'm not sure that I'm going to need that 1. Maybe I do. I'm going to have something in the numerator, and so if I'm not sure, what's going to end up in the numerator, I might need a 1 up there. I definitely need this 2 in my denominator. If it turned out you got a version that does have a number in the top and the bottom, think of it as a fraction. Reduce the fraction. I got a 1 over 2, so nothing happens there. These other 2 parts both have the same base, c. They both have exponents. It's a division problem. Subtract the exponents. 13 minus 6 is 7. The larger exponent was on the top. My answer stays on the top up there in the numerator. And since I do have something in the numerator and in the denominator, I don't actually need that red 1 that I thought maybe I would need to hold the place in the numerator. I don't need it. You can totally write a 1 if you want. It's just extra writing though. So c to the 7 divided by 2. No negative exponents. As few terms as possible. Oops. Question 3. Looks very similar to the one that we just did. Question 4. There we go. It's a different one. So evaluate the expression. Evaluate means what the rest of the directions say. Evaluate is different than simplify. Simplify means you give your answer in exponent form. Evaluate, that's what this one says, give your answer as a number with no exponents. So I'm going to deal with the exponents first to simplify, because that's going to make the problem easier to evaluate before I just start plugging everything into my calculator. So I got 2 to the power of 3, and I got 1 to the power of negative 3. All right, well, let's take this negative exponent first. Anything with a negative exponent written is part of a fraction, whether it's written as a fraction or not. This one's written as a fraction. The negative exponent's in the denominator. Negative exponent means move it to the other part of the fraction. So this 2 to the power of 3 I'm going to leave alone. The 1 is going to move up to the top of the fraction and have a positive exponent now. So those are going to be multiplied together. And I kind of lucked out in this case because 1 raised to any power, whether it's positive or negative, large number, small number, whatever, it's always going to equal 1. So I don't even really need to do anything with the red part there. 1 to the power of 3 is going to equal 1. But let's demonstrate anyhow. So 2 to the power of 3, that's 2 times 2 again, that's 4. Times 2 a third time, 8. And then I would multiply the red part. 1 to the power of 3 means 1 times 1 times 1. That equals 1. 8 times 1 is going to be my final answer. And I can do that mentally. I can do this whole thing mentally. If you get a problem with different numbers, maybe you can or can't do it mentally. I don't know. So final answer here is 8. And let's look at the next one. 5. Again, evaluate means give your answer as a number with no exponents. I got 2 to the power of 3 times 2 to the power of 3. Wow, that's the same. Inside the parentheses, that whole thing's raised to the power of 2. Let's start by simplifying first, and then we can do the evaluation later. Inside the parentheses, it's a multiplication problem. Add the exponents. 3 plus 3 is 6. Now, the 2 to the power of 6, base stays the same, just add the exponents to get 6. Now that 2 to the power of 6 is raised to another power. 2 to the power of 6 raised to the power of 2. That means I multiply these two powers together. And 6 times 2 is 12. Okay, at this point I've totally simplified, but that is not my answer because I need to evaluate and give my answer with no exponents. So I'm probably going to need my calculator this time. 2 to the power of 12, that's a lot of 2's being multiplied together. Wait, that's 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so that's a lot of 2's. So your calculator probably has an exponent button. You could type this on your calculator someplace. Probably it's got a button that looks like this. And then you'd hit 12 and you hit equals on your calculator. Some calculators have a different looking exponent button. It might be a button like this, x to the power of y. And so then on your calculator you hit 2 and then that button and 12. Or you can just hit 2 times 2 times 2 times 2 times 2 times 2. Just make sure you get it 12 times and you'll come out with the answer there. And in this case, actually my answer is really not important. The point is, can you do it, your problem? And 64 times 6, I don't know what that is. Like, that's big. Anyway, I'm going to call it quits. Move on to the next problem. Teacher's choice. All right, you guys have to do yours. I can quit early. Okay, so number 6, d to the power of 5 over a to the power of 5. That is an a. Whole thing raised to the power of -2. So I have different bases inside the parentheses. I got a d and an a. Not like bases, I cannot combine those in any way, shape, or form. It's going to stay as d to the power of 5 over a to the power of 5. But everything inside the parentheses is being raised to this additional power. If you raise one power to another power, that means you multiply exponents. So you're going to multiply the 5 times the -2 and multiply the -2 onto the other exponent, which in my case happens to be the same number. They're both 5's. So numerator, 5 times -2 is -10. D to the power of -10. Denominator, 5 times -2 is still -10. A to the power of -10. Simplify completely, it means no negative exponents. Do not use any parentheses in your answer. That means you need to simplify every possible thing. Well, I got rid of the parentheses already, but I still have negative exponents. Anytime you got negative exponents, it means the base that negative exponent is attached to is part of a fraction, whether it's written as a fraction or not. You can always put it over 1. In my case, it's obviously written as part of a fraction. Whatever's got the negative exponent, I need to move to the other part of the fraction. So the d has got a negative exponent. It's in the numerator now. I need to move it. D is going to move to the denominator and have a positive exponent. And then at the same time, or actually is the next step, the a also has a negative exponent. It started in the denominator with a negative exponent. Negative exponent means it's got to move. I'm going to move it up to the numerator. It's going to be a to the positive 10. Final answer. So you got two different terms, an a and a d. You still can't combine them, so we're going to have to leave both as part of our answer. No negative exponents, no parentheses. Totally simplified. Okay, we're number 7. We've done problems like this before, like yesterday. Okay, so these parentheses really are just being used for multiplication. There's nothing for me to do inside the parentheses. So this whole problem really is a multiplication. I got 9 times x to the power 4, and that's being multiplied by the parentheses. Inside the parentheses, the 3 is being multiplied by the x to the power 3. Everything is multiplication. It's just written in different ways. So I'm going to multiply things that are like. This is a number. This is a number. There are no exponents on the numbers. It's just a 9 and a 3, and they're being multiplied. I got 4 different things in the problem being multiplied. But when you multiply, the order of the numbers you're multiplying doesn't make any difference. So if I wanted to rearrange it, that's totally fine. I'm going to multiply the 9 and the 3 together to get 27. Then we're going to do these x's because they both have the same base. If you're multiplying 2 things with the same base that have exponents, add the exponents together. 4 plus 3 is 7. Totally simplified. Number 8. We'll start skipping here in a little bit, but we'll hit number 8. And then maybe we can start skipping a few of them. All right, so I've got 8, x, 7, y, 5, and the denominator 2, x to the power 3, y to the power of 2. All right, so I have different types of terms. The whole thing is a division problem. These are numbers. No exponents. Don't do any exponential stuff. They're just numbers. Think of it as a fraction. It's 8 over 2. You can also think of it as a division problem. 8 divides evenly by 2. That's 4. If your fraction reduces but doesn't divide totally evenly, then leave your numerator and your denominator. Probably we're going to have some more things in the rest of the problem that fall either in the numerator or the denominator. We need to make sure we have stuff for sure in the numerator. These x's both have the same base. It's a division problem. Subtract the exponents. 7 minus 3 gives me my new exponent of 4. The y's both have the same base. Again, subtract 5 minus 2 is 3. And for both the x's and the y's in the original problem, the larger exponent was in the numerator. So after I subtract, I know my answer stays in the numerator because there were more of the variable in the top to begin with. So in this case, I have nothing left in the denominator. I could write divided by 1 if I want, but that's extra writing that doesn't actually change the meaning in any way. So I'm going to leave it without the over 1 part. And then let's look at question 9. All right, look at this. We got a whole bunch of negative signs. Oh, how scary. Yikes. Okay, no, really, negative signs are scary. Okay, so order of operations, inside the parentheses first. So this whole set of parentheses, we do that first. Inside the parentheses is a D and a Z, and those are not the same base, so I can't actually combine those at all. I'm going to leave the circle here. So order of operations, parentheses. Who does parentheses? Grouping exponents, multiply, divide, add, subtract. Okay, well I have grouping symbols. They're written as parentheses. So I would have to do that first. There's nothing to do. Next comes exponents. And I know exponents show up in lots of places, but let's just think of this big red thing as a big red blob. That big red blob is being raised to an exponent. That comes second. And this negative sign, you could kind of think of it as being multiplied as -1 times that whole thing. So whether you think of it as -1 or you just as a negative sign, it takes the place of multiplication in the order of operations. And so out of the 3 things we need to look at, that happens last. Okay, let's get rid of this big red thing. Scoot all this stuff over. One thing at a time. Oh my gosh. Okay, So inside the parentheses, nothing happens. The next thing I need to do is this green exponent of -3. I have things inside the exponents that are raised to powers, and they are raised to the -3 power. That's a power to a power, which means multiply. So I'm going to take the -3 and multiply it onto each of those exponents. That -1, or just the negative sign, I'm going to wait until afterwards. That's still coming. So d to the power of -15, that's my numerator. And z to the power of -12, that's my denominator. Okay, before I do anything else, I can get rid of those negative exponents while I'm still working inside the parentheses. And then that -1 in blue will come last. So I'm going to do both things at the same time. So if my numerator has a negative exponent, it's going to have to move because it has a negative exponent. But also the denominator has a negative exponent. And since it has a negative exponent also, it's going to have to move. Sometimes people get confused and think that with a negative exponent on just one of them, we still have to trade, and that's not true. We don't trade. It's only the thing with the negative exponent that has to move. But this has a negative exponent, so it moves to the bottom. This one also has a negative exponent, so it moves. It has to move to the top. Z to the positive 12 is going to go to the numerator. D to the positive 15 is going to go to the denominator. So I've dealt with all of the exponents. There's no exponents left. This blue -1 was originally just a negative sign. You can think of it as negative sign or a -1. Either way is the same. And that has no exponents, right? It's just multiplication. So here's the easiest possible way to multiply this. Flip. Multiply the z to the power of 12 or d to the power of -15 times -1 gives me a negative answer. Okay, multiplied by -1, and now it's negative z to the power of 12 over d to the power of 15. Final answer. Yay. Okay, so now we get to skip some stuff. We've done problems like number 10 already, like number 11, like number 12. 13, we'll probably look at 13. It's not too hard, but I want to make sure we don't get tricked. Okay, inside the parentheses, -4z, close parentheses. Raise that whole thing to the power of 3. Okay. Negative numbers inside these parentheses and then being raised to an exponent, a little bit tricky. So we got to remember, here's what exponents mean. Exponents mean that whatever it is attached to, that base, in this case the whole set of parentheses, -4z, is being multiplied by itself 3 times. -4z once, times -4z twice, times -4z 3 times. Okay, and you don't have to write it out this way, but it's the clearest way for me to show you what's going on here. So in this problem, now there are numbers and there are z's. So we're going to do the numbers separately from the variables. Let's do the -4s. Red -4 times green -4 times blue -4. How many negative signs is that? There's 1 negative sign, 2 negative signs. Negative times a negative is positive. Times another negative sign makes it negative again. Final answer is going to be negative. Okay, the easier way to do this is just count how many negative signs are being multiplied together, or in this case, look at this original exponent. If it is odd, that means you're going to have an odd number of negative numbers, which means you will always end up with a negative answer. If you're raising a negative base to an exponent, if the exponent is odd, you'll get a negative answer. If this problem were different and I was raising -4z to a even exponent, then I would always have a negative times a negative is a positive. And then there'd be another negative times a negative is a positive. That gives me an even number. Or another negative times a negative is, right? Because they're always going to pair up and give me a positive answer. So an even exponent will always give me a positive answer, but I have a negative exponent. Sorry, I have an odd exponent, negative answer. That was just the negative signs. Let's do the numbers. 4 times 4 is 16, times 4 again, 64. Whoops. 16 times 4 is 64. And then let's do the z's. Z times z times z, that's 3 z's being multiplied together, so z to the power of 3. Negative 64 times z to the power of 3. Okay, having just explained that, we could do this faster. So have a quantity inside the parentheses being raised to a power. I'm going to take the power and multiply it onto the existing exponents. What exponents? Yeah, there aren't any, are there? Well, the negative 4's got an invisible exponent of 1, and the z has an invisible exponent of 1. So it's going to be the green 1 times 3. So negative 4 to the power of 3. And then the blue exponent of 1 multiplied by 3. So that'll be z to the power of 3. Okay, so to simplify it, I can just take the exponent of 3 onto both of the terms inside the parentheses. The green part now, negative 4 to the power of 3. Since I just explained this, I still remember a negative number raised to an odd exponent will give me a negative answer. A negative number raised to an even exponent gives me a positive answer, but obviously 3 is odd. So it's going to be negative 64 and z to the power of 3. Same answer, but if we know how this stuff works, it goes much faster. Okay. The rest of the problems in the assignment, I mean, there's more, but the rest of them really are very similar to things we've already done. So maybe let's look at 18. It's really kind of similar to things we've done anyhow, but 9, M6, G4, parentheses raised to the power of 3. So I'm going to take the stuff inside the parentheses that is being raised to a power. We'll put in an invisible exponent of 1 is really on that 9. So now that everything's got an exponent, all of the powers inside the parentheses need to get multiplied by this 3. 3 times 1 gives me the new exponent. So 9 to the power of 3. 3 multiplied by the 6, m to the power of 18. And this 3 multiplied by the 4 gives me the new exponent for the g. And in this case, the directions say simplify the following expression completely. Write your answer in exponential form. So we do not need to multiply 9 times 9 times 9 and find out what number that is. It says in the directions, exponential form. All done. 9 to the power of 3, m to the power of 18, g to the power of 12. And maybe we'll jump to the last one in the whole assignment. Let's look at number 21. All right, looks scary, right? It does. I agree. There's a lot of stuff here. Okay, so I have 2 sets of parentheses. Inside each set of parentheses is a bunch of stuff, but each set of parentheses also is raised to another power. So look at the first set of parentheses. I'm going to take this red power of 2, and I'm going to multiply it onto each of the existing exponents. 3 does not come with an exponent written on it, so we'll just say it had a 1. It did have a 1 all the time. We can write it in so we can see it. So I'm going to get 3 to the power of 3. No, sorry. It's a 2. 2 multiplied by 1 is 2. For the A, 5 times 2 is 10. For the B, 4 times 2 is 8. For the C, 5 times 2 is 10. Next set of parentheses. Again, a whole bunch of stuff inside the parentheses. It's all being raised to the power of 3. So I'm going to take the power of 3 and multiply it onto each of those existing exponents. So the base of 2 had an exponent of 1. 1 times 3 is 3. For the A, 4 times 3 is 12. For the B, 5 times 3 is 15. For the C, 5 times 3 is also 15. All right, so I need more space, probably. The directions here say simplify. It does not say anything about writing my answer in exponential form, so I am going to actually multiply out my numbers. 3 to the power of 2 is 9. And then in green, 2 to the power of 3, that's 2 times 2. 4 times 2 a third time is 8. Okay, and now, final answer. Everything here is being multiplied. I could put the times dots in so it's easier to see, but it's all being multiplied. It was being multiplied in the first place. Originally, inside the parentheses, all this stuff's being multiplied together. Inside this set of parentheses, all being multiplied together. Between the parentheses, also being multiplied together, but I had to do those exponents outside the parentheses first. So, to get my final answer, I can only combine things that have the same base. The 9 actually does not even have an exponent on it. It's just a number. It's a 9. Same with the 8. It's just a number. I need to multiply them together. I could rewrite it if I wanted. I don't really have any space left to rewrite it. But if I wanted to rewrite it so that the like things were written right next to each other, you could totally do that. Some people find it helpful. I'm just going to multiply 9 times 8. 72. And then I'll try to use, I know I've already used colors. I don't have any more colors to go here. So the A's, I got a base of A with a power of 10. I got a base of A with a power of 12. It's a multiplication problem, which means add the exponents. 10 plus 12 is 22. Next, the B's. So I got B to the power of 8, B to the power of 15. Still multiplication problem. Add 8 plus 15. It's 23. Lastly, base of C has an exponent of 10, and this one's got a power of 15. Add those together. It's a multiplication problem. So you add the exponents. 10 plus 15, 25. Final answer. All right, happy mathing. Hopefully that addresses all your questions.